holes are still somewhat of a mystery to us. However, that may not always be the case. What we do know is that they're pretty scary, and our galaxy alone is thought to contain at least 100 million of them. Yes, 100 million. Hello and welcome back to Life's Biggest Questions. I'm Rebecca Felgate, and today I'm asking what would happen if Earth fell into a black hole. Black holes are wandering around our cosmic hood. Their gravity is so dense that they're not stuck in orbit of other objects. They also don't emit any light or radiation, so you can't see them, making it hard to know exactly where they are. We can, however, see the hole's effect on nearby matter. Unless there is a lot of nearby matter, black holes can sneak around undetected. There are two types of black holes: supermassive black holes, which are at the heart of every galaxy, and stellar mass black holes, which are the ones that can really creep up on you. The nearest stellar mass black hole we know of is thought to be just under 3,000 light years away and is about 9 times the mass of our sun. So what is a black hole exactly, and why would it matter if we got too close to one? While there is no doubt that we have a lot left to learn about them, black holes are very, very dense. They're so heavy that they start to bend space and time inwards. Obviously, if they're able to bend space, black holes are denser than our sun, which means if one came close to the Earth, the gravitational pull of our solar system would shift. This would mean planets would be torn from orbit and likely smash into one another. If we were able to avoid any planet smashing, we would quickly discover that Earth has become a dartboard for asteroids. Asteroids orbit too. As much smaller rocks, they would be easily torn from their current paths and hurled towards Earth. This would not be ideal, as this could cause widespread death and destruction, and possibly a number of fires. If we, by some chance, managed to survive that, the next part would actually end humanity altogether. As we're drawn closer to the black hole, our atmosphere would be torn away and sucked in. Then, parts of the planet would break up itself. Also, the radiation created from all the other broken apart materials from other planets and cosmic junk would be very, very intense. We might be dead, but what happens then? What happens when we cross the event horizon and start traveling inside that hole? Well, honestly, we don't really know, but there are some key theories out there. The first is of spaghettification. Some scientists think that at the bottom of a black hole is one point of singularity. Our Earth would be broken apart molecule by molecule in a funnel effect, leading down to this very dense point of singularity. We would be stretched out like spaghetti, so thin that we would exist atom on top of atom. There are other theories that black holes aren't actually black holes, but doors to the other side of the universe. I don't want to mind boggle you, but as black holes already bend time and space, many think that they fold time and space, and that matter comes out the other end and expands outwards, like a big bang. We know that our universe is expanding. We can see it. We know that it started in a very hot, dense place and exploded outwards. Could we have come out of a black hole? Another theory is that if Earth fell into a black hole, we actually wouldn't even notice. Some scientists believe that instead of being destroyed, any material that touches a black hole turns into a near-perfect hologram. So far as we're aware and can hypothesize, the only way to escape being sucked in by a black hole is to travel faster than the speed of its gravitational pull. So, faster than the speed of light, which is something we're not even close to being able to do. Our solar system has been doing fine for 4.5 billion years, which suggests that we've never come into contact with a black hole yet, so we probably shouldn't even worry about it too much. That being said, there could be a risk of black hole danger on Earth itself. Scientists have created something called a Large Hadron Collider. This smashes particles together and is thought to be able to create a black hole. This collider costs billions of dollars and is designed to help us understand particle physics and the origins of the universe, but it could be powerful enough to generate a miniature black hole.
Astronomers estimate that there are as many as 100 million black holes in our galaxy alone, and that there is a supermassive black hole at the center of almost every galaxy. Black holes are still quite mysterious. We don't really know a lot about them. Works of science fiction allow us to imagine that black holes could serve as gateways to other worlds. As far as we know, going inside a black hole is not not the smartest idea, unless you want to turn into human spaghetti. But according to Professor Stephen Hawking, black holes could be wormholes that could provide shortcuts for interstellar space travel, which otherwise would be pretty slow and tedious. A wormhole, aka an Einstein-Rosen bridge, is essentially a shortcut through space-time. So let's expand on this idea in today's episode of Life's Biggest Questions and ask, what if humans could travel through black holes? Welcome back to Life's Biggest Questions. I'm Charlotte Dobre. This is where I remind you to hit the like, subscribe, and notification bell and ask us a question in the comments below. On this channel, we post 1 to 2 topics a day, so it's quite possible that we may have already made a video on one of your suggestions. Make sure you search our videos to see if we have. And if you would like to connect with the creative team behind Life's Biggest Questions, check out the description for all the links to our social media accounts. The idea of black holes has actually been around for a couple of hundred years. John Mitchell of Cambridge University wrote about something he called dark stars back in 1783, now known as black holes. Most scientists believe in the idea of the singularity, where a huge amount of matter is shoved into a tiny space, making a black hole. The gravity of a black hole is so intense, it is impossible to escape, even for light. The edge of a black hole is called the event horizon. It's the point of no return. Imagine the edge of a black hole as being a waterfall. Once you go over the edge, you can't climb out, unless you happen to be capable of traveling faster than the speed of light. As you get closer to the black hole, the speed needed to escape goes up, and at a certain point, the escape velocity needed to leave Earth's surface is about 25,000 miles per hour. Just for some comparison, considering that time only goes forwards and never backwards, once you went through a black hole, you would be annihilated. There is, however, a way around this. We know that gravity bends space, but black holes are not ordinary objects. If black holes were able to rotate like other objects in space, then they could theoretically turn into a ring if they rotated fast enough. A ring singularity could provide a gateway to other universes, other time periods. This is what's known as a wormhole. The term wormhole was coined by physicist John Wheeler in the 1960s when he was examining the work of Einstein and Rosen. An Einstein-Rosen bridge is a tunnel through the universe that's essentially like a shortcut between 2 points in space. No one really knows what happens to all the matter and light that enters a black hole. So where does it go? Is it lost, or does it come out the other side? In a speech from 2015, Stephen Hawking said, "Black holes are not the eternal prisons they were once thought. The way out wouldn't take people back to where they came from, but instead they would reappear, but somewhere else. Perhaps in our advanced future, once we have used up all the resources on planet Earth, whatever remains of humanity will have to use wormholes to find other areas of the universe to inhabit. And maybe a wormhole could give us access to an alternate universe with other habitable planets. These habitable planets could be barren or already taken over by another intelligent civilization. Maybe this would mean that we would be forced to live alongside an alien civilization, or an interstellar war would begin. Let's hope this advanced alien civilization is nice and could share their knowledge of the universe with us, and together we could colonize the cosmos. Unlimited destinations for space travel would be at our disposal. Water worlds, fire worlds, rocky worlds, whatever you can imagine. We could also possibly use wormholes as time machines. We could theoretically alter the future by changing the past. Maybe we could go back in time and find out who shot JFK. Maybe we could try and stop Hitler. But changing the past could have dire consequences. One could literally erase our entire existence if they weren't careful. The ripple effect of changing one small thing from the past is incomprehensible to us. That being said, Stephen Hawking said that if we could travel through black holes, we wouldn't be able to come back to our universe. Once you entered a black hole, that's it. You're on the other side. And according to new research by postdoctoral fellow Peter Hintz, whoever traveled through a black hole would leave their past behind, and before them there would be an infinite number of possible futures. Yes, entering a black hole could take you to an alternate universe, but it would also delete your past, skew reality as we know it. Now as we come back to our reality, I will say that no one has really figured out the math of a wormhole to make it so that the gateway remains stable. Furthermore, no one really knows how a wormhole could come into existence. At this time, it's most commonly believed that if you entered a black hole, your mass is simply added to the black hole. You don't go anywhere. You would become stretched out into individual atoms by epically strong tidal forces. As you fall closer to the event horizon, eventually all you will see is blackness before you are dragged at the speed of light and stretched out into strings of atoms. This is what's known as spaghettification. Definitely one of the worst ways to die, and we don't recommend it. That being said, no one knows what happens beyond the event horizon of a black hole. Scientists currently don't know what happens when you exit the universe. We are nowhere near close to any black holes, let alone able to see what happens when we enter one. All we can do is use Einstein's theory of relativity to work out what might happen.
Black holes. Black holes fill me with dread, but probably only because there is so much mystery surrounding them. Should we be scared of them? Hello and welcome back to Life's Biggest Questions. I'm Rebecca Felgate, and today I'm asking, what is on the other side of a black hole? You guys seem to enjoy our what would happen if Earth was sucked into a black hole video so much that we thought we would delve deeper and decipher part of this mystery for you. Despite the mystery surrounding black holes, it is estimated that there are as many as 10 million or maybe even more in our our galaxy, the Milky Way, alone. There are two types of black hole that we know of: supermassive black holes, which are at the heart of every galaxy, and stellar mass black holes. Supermassive black holes have the mass of millions of stars, and stellar mass black holes are still dense but on a much smaller scale, and they can move. We don't really know how supermassive black holes formed, but we do have some insight into stellar masses. This stellar mass black hole comes from the gravitational collapse of huge stars. Our sun, for example, would not be big enough to form a black hole. When stars, roughly 25 times the size of our sun, reach their end-of-life phase, they become supernovas, exploding outwards, but also imploding inwards, buckling under their own mass. Hole is perhaps not the right word for a black hole, because they aren't exactly empty. They're actually very, very dense. So dense their gravity is so strong that they start drawing in other matter around them, and not even light can escape them. Time and space buckle around black holes, and the laws of physics as we know them start to break down. So what happens inside one, or what's at the bottom of one, or is there even another side? The true answer is we don't exactly know, but there are some key theories. As I said, black holes are dense. What's inside a black hole is the collapsed matter of the star, and in theory, this collapse goes on and on and on until things get thinner and thinner and denser, leading to a point of singularity. This is one theory anyway, and possibly the most credible. However, there are a number of theories as to what goes on beyond the event horizon, the moment something starts getting deconstructed by a black hole. The theory of loop quantum gravity suggests that there is no singularity, but black holes are simply folds in the universe. Everything we know about quantum physics tells us that information is never lost, that energy can't be created or destroyed, so perhaps black holes are folds or portals to older universes. We're gonna get very deep for a second, so hold on to your hats. Our main theory about the formation of the universe is that it came from one hot, dense point of singularity that expanded outwards, the Big Bang, if you will. The formation of the universe seems like the opposite of a black hole, which sucks in and deconstructs matter into a smaller and smaller amount of space-time. Perhaps the point of singularity in a black hole, the end point, if you will, is the starting point of another universe. This is pretty much what is discussed in the Big Bounce theory. So these are stellar mass black holes, the easiest type of black hole to study, as we cannot get anywhere near a supermassive black hole. There may be another type of black hole too. According to a NASA Q&A page, mathematicians and physicists have theorized that there are hollow black holes that don't require the collapse of a star to form. This type of black hole is imagined to have an exotic geometry and be a place where time travel is possible. Well, blimey, NASA, careful where you're spilling that huge can of worms. But of course, before we all get too excited, we should remember that time travel will only be possible if we're ever able to manage to move faster than the speed of light, which of course right now we're very much unable to do, but maybe one day. There is one more interesting thing to say about black holes, and that is they tend to leave ghosts behind them. By that I mean, as Stephen Hawking observed, the information contained in matter that falls into a black hole seems to be copied and frozen around the event horizon. As NASA puts it, this raises some interesting possibilities that we could resurrect clocks, humans, spacecraft, and whole planets into something like their pristine form if we could magically reverse the infall and collapse process. Whew. Well, I think that is enough for one day. Fundamentally, the short answer is we don't know what exactly is on the other side of a black hole, but we have some good theories. We suspect it's infinitely dense, and some suspect it could be a portal to a new dimension.
Space. It's a pretty weird place, isn't it? Whether it's timey-wimey, upside-down stuff, strange exoplanets that rain torrential downpours of pure glass, entire cosmic oceans of neon gas, white dwarfs, red dwarfs, or perhaps the weirdest, most mysterious linchpin of all these space-time shenanigans combined, the black hole. The void itself, the dark maw of the universe, the biggest fan of theoretical spaghettification of all time, and I do mean all time because as we all know, time is a relative concept, right? Or is it a flat circle? I forget. But anyway, what if we took that mysterious cosmic void, threw caution to the wind and, I don't know, dropped a nuke in it? Just for the sake of it. Really? What would happen? Well, let's find out. Hello internet, what's going on? And once again, welcome back to the most inquisitive channel on YouTube, Life's Biggest Questions. As per usual, I'll be your disembodied floating voice, Jack Finch, as today we curiously ask the question, what if we nuked a black hole? Roll the clip. For the curious amongst you, that clip was of course from 2009's Star Trek, directed by J.J. Abrams, because, you know, this is a video about black holes. And you deserve nothing better than the most cinematic visual depiction going. Or, well, the most appropriate, I guess. Anyway, it leads us to an important notion, because the fact of the matter is, despite their best efforts, fiction has tried its damnedest to try and visually theorize exactly what's going on down in the deep dark bowels of a black hole, but the reality remains that no one exactly knows what would happen if we plummeted headlong into the void. It could be a portal to another dimension, but it also could be a cosmic trash compactor that obliterates matter with its infinite density. But sometimes, as they often say, the truth is stranger than fiction. You see, the conceptual idea behind black holes has permeated its way across the scientific community for over 200 years, culminating recently with the first ever actual visual photograph of the coveted black hole. We took a photo of it, guys, and that's awesome. If you didn't know though, the first ever mention of something resembling a black hole was way back in 1783, theorized by a Cambridge don by the name of John Mitchell, who had written a paper in the Philosophical Transactions of the Royal Society of London about what he referred to as dark stars. Mitchell noted that any star that was sufficiently massive and compact would inevitably have such a strong gravitational field that even light itself could not escape. Well, of course he was right, but it wasn't until 1915 when a particularly brilliant mind, our boy Albert Einstein, put forward his revolutionary general theory of relativity, and suddenly space and time were no longer thought of as independent entities, but instead just different metrics of a single object, space-time. And now it was all neatly mashed together. Space-time wasn't flat like the previous two parameters. It was warped and curved by the massive manner of matter and energy bounded across the cosmic expanse, and those curves and warps were dictated by the endless indents upon them and inside them, black holes. The result of what happens when a star gets too big for its boots and its density becomes even bigger than the Beatles. Well, of course he was right, and he sparked an interest in another particularly brilliant mind, Professor Stephen Hawking, who dedicated his cosmic joy of life to figuring out pretty much anything and everything of what the hell is going on with all these black holes. But guess what? Despite the indifference of Professor Hawking, we're going to theoretically send a nuke into one. But the first question is, which one? How many black holes are there? How are we even going to get into the position of shooting a nuclear rocket into it? Surely it's not as easy as firing off a missile from the surface of our planet and hoping for the best, right? Well, wrong. Of course, space is big, guys. Heck, our galaxy, the Milky Way, is really big, as in 180,000 light years in diameter. And bad news, because the nearest theorized black hole to our pale blue dot is 3,000 light years away. The fastest thing that we've ever created is the Helios 2 probe, which was launched way back in 1976 and travelled at a record speed of over 157,000 miles per hour, and incredibly enough is still in orbit around our sun today. Now, 157,000 miles per hour is incredibly quick, but when compared to travelling the distance of a single light year, yeah, it doesn't look too hot, does it? To travel one single light year at 157,000 miles an hour would take 4,269 years. And unfortunately for us, the nearest black hole, as we said, is 3,000 light years away. Guys, I hate to break it to you, but even if we sent a nuke right now that could travel at the speed of Helios 2, it would take 12,807,000 years to even conduct our experiment. And, well, as they say, ain't nobody got time for that. In fact, if black holes were cosmic portals to another dimension, it's entirely hypothetical that if we sent off our nuke and 12 million years passed for us to find out what happened, humanity and our planet could have come and gone, and we'd have disappeared entirely, lost in the sands of time, before we even found out the result. And perhaps we'd have never found out that our nuke that we haphazardly shot into another dimension actually landed smack bang into another planet, destroying it completely. It's the perfect crime, really, but we all know better than that, don't we? We don't just shoot off nukes without considering the potentially destructive consequences. So let's say that our civilization had finally figured out faster than light space travel, and a team of scientists headed over to our galaxy's nearest black hole with a nuke strapped to their vessel. They positioned themselves at a safe enough distance out of the gravitational pull of its event horizon. They hit the big red button, and the nuclear bomb plummets its way into the black hole. And what happens? Well, under our current understanding of physics, absolutely nothing. but not in the way that you may think. You see, within a black hole's event horizon, energy and matter become one, and those very same black holes can convert any varying degree of energy into mass. It gets bigger, guys. It's a black hole. And as we know, a black hole's mass is infinitely dense. Anything that happens in our universe, nuclear detonation included, denotes information, and thus information requires energy, and energy has mass. E equals mc squared. And, well, a nuclear bomb has a hell of a lot of energy. In fact, a 1 megaton nuclear weapon releases energy equivalent to 4.18 times 10 to the power of 15 joules. While that's absolutely massive, that's only small fry comparative to the largest nuclear weapon ever detonated, the Tsar bomber created by the USSR with a yield of over 50 megatons. Whatever the degree of magnitude, if we fired our hypothetical nuke into a black hole, the likely outcome is that it would just add fuel to its fire. Our gigantic explosion would serve only to convert that entire dense and enormous mass into pure, unbridled energy, and again, as is the mechanics of a black hole, convert that energy back into mass. You see, it wouldn't matter how many nukes we sent into it, or how powerful they were, because in all reality, we could crash an entire star into a black hole, and it would still gobble the whole thing up, only getting bigger and bigger, chewing up the universe as it goes. Thankfully for us though, Professor Stephen Hawking theorized that black holes eventually dissipate their mass over a long enough passage of time. Given enough breathing space, even the most supermassive of black holes will eventually evaporate away into a harmless soup of particles. Well, theoretically, anyway. So for the time being, it's probably best to not fire any nukes into a black hole, or at anything really, except an asteroid hurtling towards our planet. Yeah, we can nuke that. Safety first. Black holes and revelations, I guess. But as a Muse plug aside, the very nature of these cosmic anomalies is the stuff of hypothetical legend, because it's no secret that we humans are equal parts intrigued and equal parts terrified by the reality-bending mechanics of what black holes are, what they could be, and what they're going to do. Because if we're correct, at the end of all things, only black holes will remain. But until then, as the question is so often raised, can we do anything to combat the eater of worlds, the singularity, the black hole? Or do we just have to close our eyes, avoid their gaze, and hope that they will just fizzle out on their own? Let's find out. Hello internet, what's going on? And once again, welcome back to the most inquisitive channel on YouTube, Life's Biggest Questions. As per usual, I'll be your disembodied floating voice, Jack Finch, as today we curiously ask the question, can a black hole be destroyed? Roll the clip. That scene gets me every time. But for the curious amongst you, that clip was from Danny Boyle's 2007 science fiction work of art, Sunshine, starring the remarkable Cillian Murphy as a physicist whose mission is to literally blow up the sun with a nuke. And I don't know about you, but I'm pretty sure that sounds like a quickfire way to get yourself the particular cosmic construct in question of this video. Now, obviously that's a pretty loose connection, and that's also not how it works, but hey, this is a hypothetical of science, and as far as science fiction goes, Sunshine is a phenomenal film. But it leads us to our first and most important point when addressing this question. Can a black hole be destroyed? Well, you see, as Sun Tzu so famously said, if you know the enemy and know yourself, you need not fear the result of 100 battles. Or, as Zach de la Rocha also more succinctly said, know your enemy, dun 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 dun. So, then it would make sense that if we're wanting to address the question of finally putting an end to a black hole, we must more importantly need to understand how and why they are created. The whole process first begins with a pretty special star, one that adheres to the Chan-Rasikar limit, a star that has a minimum mass of 1.6 times the mass of our sun. As this star reaches the end of its life and thus begins to run out of the hydrogen and helium fuel which it uses to power itself, the gravity which holds it together gradually takes over entirely, and it shrinks to such a tiny size, and as it crosses its predefined Schwarzschild radius, there we have a newly formed black hole. Obviously, there's a lot more to it, but as you may have imagined, we're more concerned with how and even if we can destroy these cosmic destroyers. The thing is, in several ways, the answer to this question is surprisingly mundane. You see, a black hole's biggest enemy is itself, and in many ways, it may be the only way for it to finally bring about its own demise. Now listen, don't worry, we're going to be taking a stab in the dark at a few potential spacefaring tactics to take down a black hole, but the first and most important void elephant in the room that we need to address is the fact fact that each and every black hole is pretty much slowly dying already. Anyway, let me introduce you to a little thing known as Hawking radiation. Back in 1974, the legendary mind of British physicist Stephen Hawking harnessed the quantum mechanics of the science of the very small to theorize that each and every black hole gradually loses its own mass. Hawking radiation is based on a well-established phenomenon called quantum fluctuations of the vacuum. Essentially, Hawking turned his gaze to the very edge of the black hole, the event horizon, where particles and antiparticles continuously create and destroy each other. Yeah, black holes, am I right? The thing is though, right at the edge of this occurrence, Hawking noticed that if these particles and antiparticles are positioned just right, there is a slight possibility that one of the particles could escape the black hole's gravitational pull whilst its counterpart falls inward. And there we have, in essence, Hawking radiation, a slow leak that is inevitably reducing the black hole's mass, thus leading it to be destroyed. The largest of which will be in about 6 times 10 to the power of 99 years, which is, yeah, that's a long time, guys. We're talking quadrillions upon quadrillions of years. But don't worry, the heat death of the universe will have already occurred, and there'll only be black holes left to witness the utter abyss of the end of all things. Sorry about that. So is that it? To destroy a black hole, do we just wait for it to destroy itself? I mean, we wouldn't be around to witness its demise, but hey, at least we can rest easy knowing that it would be destroyed. Eventually, that is, I guess. Well, I'm not sure about you, but maybe there's another way. Now, if you're an astute observer of Life's Biggest Question, you'll know that we've hypothetically envisioned all manners of how to bring about the end of these cosmic destroyers, most infamously being that time where we wondered what would happen if you shot a nuke straight into it. Yeah, and yeah, as you may imagine, just like Godzilla himself, all of these battle tactics have only ever served to make them even more angry. Nukes, cosmic tornadoes, lions, tigers and bears, all of which only serve to strengthen the combined power of a black hole, given the fact that in the singularity, energy is mass and mass is energy, and throwing in either of the two simply feeds it like the terrifying, ravenous cosmic maw that it is. Alright then, in that case, it's probably time to up the ante. Let's bring out the big guns with everyone's favorite anomaly, antimatter. And as the name suggests, antimatter is exactly that, the opposite of regular matter. And as we're also taught by mathematics, if we add a positive and a negative together, they just cancel each other out, right? So why don't we just create our own black hole out of antimatter, fire it into the black hole, and then call this whole thing a day, dust off our shoulders, and move on to the next cosmic villain? Well, it's not that easy. Just ask the folks over at CERN, who operate the Large Hadron Collider, a particle accelerator which fires tiny particles against each other in the effort of creating all manners of cosmic entities. But the thing is, the cost of creating something out of antimatter is, well, it's pretty damn staggering. NASA speculates that a single gram of anti-hydrogen would cost around $62.5 trillion US, and that's under the presumption that scientists had already worked out the math in the effort to smash together these incredibly expensive anti-hydrogen particles in the effort of creating an antimatter black hole. And that's also without addressing the fact that, well, under those circumstances, we would have created an antimatter black hole on our own planet, and I'm pretty certain I don't need to illustrate just exactly why that would be a very bad thing. You see, even if we did manage to safely do that and then somehow figured a way to catapult an antimatter black hole into a regular black hole, then the result would be an explosion of pure energy. It would be the most perfect weapon of pure energy that theoretical physics can envision. And yeah, I hate to break it to you, but we just get twice the black hole. E equals mc squared. As soon as that explosion occurred, all of that energy would immediately be converted into, well, more black hole. Yeah, sorry guys, but it's probably best that we just wait this one out. Hawking radiation, yeah, it's our only hope.
2020 has been a year filled with tragedies. We started the year off with the threat of World War III, then we lost numerous legends. Now we are plagued by a deadly virus and murder hornets. What's the next level of Jumanji? Black holes entering our solar system? Let's hope not. Hey everyone, what's up and welcome back to Life's Biggest Questions. The voice you are currently listening to belongs to me, Lindsay Ivan, your voice of reason for today's video, which is what if a black hole entered our solar system in 2020? But before I begin, make sure to give this video a big thumbs up and subscribe to Life's Biggest Questions. With that being said, let's dive on into the video. To understand the effects that a black hole could have on our solar system, we first have to understand what a black hole is. Black holes are very interesting and fascinating. The term black hole was coined in 1967 by American astronomer John Wheeler. The first black hole ever discovered was spotted in 1971. A black hole is a point in space where gravity is so strong that nothing around it can escape. not even light. NASA states the gravity is so strong because matter has been squeezed into a tiny space. So far, astronomers have identified 3 types of black holes: stellar black holes, intermediate black holes, and supermassive black holes. Stellar black holes can be up to 20 times more than the mass of the sun. They occur when a large star burns through its fuel and collapses into itself. Then we have intermediate black holes. This is a mid-sized black hole. These are formed when stars in a cluster collide in a chain-type reaction. And lastly, we have supermassive black holes. These may be the result of hundreds or thousands of tiny black holes that have merged together. Their masses are more than 1 million suns combined. Now, they're said to be supermassive black holes at the center of galaxies. It is said that they don't pose a threat to us at this point in our lives. They only will when our galaxy collides with another galaxy, but that isn't said to happen for another few billion years. But let's assume it did somehow happen and a black hole is now in our solar system. What would happen? Well, once black holes spawn, they gather mass from the dust and gas around them. This allows them to grow in size, aka Earth and our solar system would fall into this black hole and we would be engulfed in it. This would happen in a process scientists refer to as spaghettification. Let me explain. Basically, spaghettification is a theory that suggests that the gravity in the black hole would stretch you out like spaghetti. I mean, I love spaghetti, but I don't want to be turned into a human noodle, thank you. Let me explain this process. Let's say you were headed feet first into the black hole. Your feet are physically closer to the black hole, so they would feel a stronger gravitational pull than your head would. So your feet are being pulled in further, which is stretching your body. Now, your arms. Because they aren't at the center of your body, it would cause your body to be pulled inwards, making you appear very thin. So basically, if we did get sucked into a black hole, we would all be compressed and elongated, looking like human noodles. But that's not all. This spaghettification process would not only happen to us humans and animals, but also the whole Earth. The edge of the Earth closest to the black hole would be pulled in and would be stretched and flattened. Our whole world would basically be pulled apart. Here is another theory as to what could happen. Maybe we wouldn't be wiped out by turning into spaghetti, but maybe we would be killed first by the radiation. A study done on black holes by NASA discovered that when a supermassive black hole consumes gas from a star, it results in an outburst. Basically, it's when hot gas forms and then disappears. Well, it's said that this gas can be anywhere from 1 million degrees Fahrenheit to about 2.5 million degrees Fahrenheit during these outbursts. On top of that, black holes are freezing cold on the inside, but incredibly hot on the outside. So it's thought that before we could even be spaghettified, we would be fried by the radiation. Now, let's talk about supermassive black holes for a second. This black hole is so big that it could wreak havoc on our solar system from a distance of a few light years away. First off, it's said that it has stars, planets, asteroids, and comets orbiting around them, along with a bunch of space debris it picked up on its route to us. Well, all this stuff would then come crashing into our solar system. We would probably be wiped out by some rogue planet smashing into us. This theory was noted by World of Science. Okay, so we have no chance at survival with supermassive black holes. But what about stellar black holes? Maybe they'll go easy on us. Well, it's theorized that if this black hole came into our solar system, then it would completely mess with the Oort cloud. The Oort cloud is basically a shell of icy objects that's said to exist in the outer parts of our solar system. Well, it's said that the black hole could possibly mess with the Oort cloud's gravitation. This could cause these giant icy comet-like asteroids to come flying towards our planets. AKA, we would be killed by tons of these objects hurtling towards the Earth. But that's not all. If a black hole entered our solar system, it could pull the gas from Jupiter until it was consumed entirely. Then this could mess with our orbit. Maybe it would pull us into an area in space that's inhabitable. Then we would die from this drastic change. As the black hole nears Earth, it could also cause the Earth's crust to crack. This would cause deadly natural disasters like huge earthquakes and volcanic eruptions. Not only that, but the ocean tides would also wipe us out. Meaning that by the time Earth actually got into the black hole, it would be nothing. It would be completely wiped out of all humans. It would just be surface paved with magma. Another theory is that if we did encounter a black hole and it got close to the sun, it would start to consume the sun's gas. This would pull Earth's center of gravity towards it, tearing it to shreds. Now, we are thinking about the worst case scenario here. Let's see what NASA has to say. When asked if a black hole could destroy Earth, NASA responded with this. They claim that even if a black hole the same mass as the sun were to take the place of the sun, Earth would still not fall in. The black hole would have the same gravity as the sun, and so the Earth would continue to orbit around the black hole as it would the sun. Except, NASA, the sun is our main heat and light source. You failed to mention that. Sure, Earth would still be alive, but would we still be able to survive? The core of the sun is approximately 27 million degrees Fahrenheit. Meanwhile, supermassive black holes emit gas that is around 1 to 2 million degrees Fahrenheit. That's millions of less heat getting emitted towards Earth. That difference in heat could make or break us. Who knows if we could survive on an Earth that is drastically colder. On top of that, we wouldn't get the same amount of light to grow crops. Overall, it seems very, very unlikely we would be able to survive living close to a black hole. But good news! NASA states that the sun will never turn into a black hole. They say that the sun is not a big enough star to make a black hole, so we're safe for now. Lastly, a theory proposed by Dr. Samir Mathur from Ohio State University says that black holes could create holograms out of Earth. In his theory, he states that a black hole wouldn't destroy everything it touches. In fact, he suggests that we wouldn't even notice if Earth got swallowed by one. He goes on to say that, and I quote, "Material touching a black hole instead becomes an imperfect copy of itself, continuing to exist as before." So basically, we would be photocopied and we would go on with our lives, not knowing that we're living in a black hole. Either way, let's hope that a black hole never enters our universe. That would just be the ultimate end to 2020, quite literally. Before I end today's video, I'm going to be doing a quick comment shout out for my last video, Top 10 Spiders Scarier Than the Murder Hornets. OG Butter commented, "Stop giving 2020 ideas! I'm sorry, okay? Seriously, what's next to come?" Let's hope nothing. It feels like we're in a video game and we just keep completing these levels and moving on to the next stage. The only question is, who or what is the final boss? Noah Dennis commented, "What if SpongeBob was real?" Oh man, I've seen pictures of what the cast of SpongeBob would look like if they were humans, and it's terrifying. That Lenny guy commented, "Wow, yes, exactly. Wow," that's all I have to say. Wow, wow, Owen Wilson. And that's all the comments I'm shouting out for today's video. Make sure to comment something down below for a chance to be featured in my next comment shout out. And as always, don't forget to give this video a big thumbs up and subscribe to Life's Biggest Questions for more thought-provoking videos. I've been your host, Lindsay Ivan, and stay curious, YouTube.